either one root or you can get two roots. And if you get one root, it will be one root twice. So you get two solutions that are identical. Okay? Sometimes you can get two solutions that are unequal or that are different. Right? Now, when you have the quadratic formula, okay, which can be simplified and be written in two forms like that, you get two solutions. Now, the expression inside the square root, this b squared minus 4ac, is the one which is used to determine the nature of roots. By nature of roots, we are saying, are the solutions real numbers? Are they rational? Are they equal or unequal? If they are rational, you can have a different case. Okay, you can have rational and then you can have two roots that are equal. Okay? Now, sometimes you can get irrational roots, okay, whereby the discriminant will be a non-perfect square. For you to get rational roots, the discriminant must be a perfect square. But being a perfect square or a non-perfect square is not the nature of roots. The nature of roots is that they are real numbers, they are rational or they are irrational. Are they equal or unequal? That's what the nature of roots is all about. Okay, so if you are asked to discuss the nature of roots and you say that the nature of roots is because of a perfect square, what is the perfect square? All you'll be saying is that the discriminant is a perfect square. But how does that help us to determine the nature of roots? So whenever you get a question on nature of roots, right, if delta is equal to 0, okay, if delta is equal to 0, the discriminant will be, okay, in that case, the discriminant will be 0, therefore, you get two roots that are equal, okay, and both roots will be real numbers, and they will be rational as well, okay, so that's the case when delta is a perfect is equal to 0. Then you can also have a general case where you may be asked to prove whether the roots are real numbers or not. If they are real numbers, means delta must be greater than or equal to 0. If delta is equal to 0 or greater than 0, then you get real roots. At that stage, we are not concerned about whether the roots are rational or irrational. We just want to know, are the roots real numbers or not? Then it means your discriminant must be greater than or equal to 0. Then, if the discriminant is greater than 0, and you have obviously, if the discriminant is a perfect square, it means you get roots that are real numbers. At the same time, they are rational, and also they will be unequal. All right? Then we have another case where delta is also greater than 0. That is, the discriminant is greater than 0, but delta is not a perfect square. In that case, you get roots that are real. They will be irrational because you can't find the square root of a non-perfect square number. And obviously, the roots will be different or they will be unequal. Then we have got the unique case where delta is negative. In that case, your roots will be non-real. Okay, please, that's the proper word, non-real. No other word. So in this case here, the roots will be non-real. Okay? Because you don't get into the details of a case like this in high school, you cannot say the roots are equal or unequal. And you can't say they are rational because they are not rational. They are not irrational. Okay? If you have got a discriminant which is negative, you will never get roots that are rational or irrational. Please. Because I saw that some of you writing that. If delta is a negative, you only state that, okay, the roots are non-real. That's it. They are neither equal or unequal, and they are not rational or irrational. They are not. So it's better to just say undefined, undefined, or not applicable, not applicable. That's it. So you need to make sure that you are familiar with this. Okay? The nature of this. the nature of roots is here, this column here. That's the nature. So when you get any question about nature of roots, your answers after doing your calculation using the value of the discriminant, you don't have to find the square root of the discriminant. The square root of the discriminant is not the discriminant. Okay? Your discriminant is the expression b squared minus 4ac. If you know the value of a, b, and c, you just substitute. You get a value. That value is your discriminant. Don't try to do anything to it. Okay? Please be aware that the square root of b squared minus 4ac is not the discriminant. But the discriminant is b squared minus 4ac, which we call delta. Okay? We just denote the expression b squared minus 4ac by delta, which is a b. Don't confuse the actual quadratic formula x equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Your discriminant is just a part of the quadratic formula, and that part is the expression inside the square root. Okay? That b squared minus 4ac is the discriminant. If the discriminant is negative, you get non-real roots. Okay? If the discriminant is equal to 0 or greater than 0, you get real roots. Please be aware that your discriminant is this expression here. It's a binomial b squared minus 4ac. That's the discriminant. Don't think about anything else, please. Okay? Now, the discriminant is very important because it has got applications which you are going to encounter later on. I'll do some examples. And also, when you do the quadratic function in grade 11, you are going to encounter some questions where you need to apply it. So make sure you are aware of it. All right? Then, we can incorporate the quadratic function. Okay? At this stage, you know that the quadratic function in grade 11 has got a turning point, or rather an axis of symmetry along the y-axis, okay, at grade 10 level, okay. So in grade 10, the axis of symmetry of the quadratic function is the y-axis, which has got the equation x equal to 0, right? In grade 11, the axis of symmetry is going to move to the left or right of the y-axis. So we have got three scenarios based on the nature of roots. Okay? So if the turning point is not below the x-axis, if it is above the x-axis, it means you have got non-real roots. You never encountered a situation like that in last year. When you sketch the quadratic function in grade 10, you never had a situation where the turning point was above the x-axis. Okay? Every time when you sketched it, if the turning point was above the x-axis, okay, like this, it means you don't get any roots. Okay? Of course, you encountered a situation where the value of a was negative and the maximum turning point, where the turning point was above x-axis, but it was touching the what? The x-axis. So you can have the turning point above the x-axis or the turning point below the x-axis. If you get any of those two scenarios, means there are no roots. So the second case which I'm talking about is this. You can have a situation where the turning point is like that. Okay? It's below the x-axis. If the turning point is above the x-axis or below the x-axis, like this, these two scenarios here, it means that you won't have real roots. So what that means is there are no x-intercepts for that quadratic function. There are no x-intercepts. The x-intercept will be undefined. They will be complex numbers. In fact, they don't exist at all. So you can have a situation like that. Then you can have a situation where the turning point is on the x-axis, which means that turning point, there is one x value here. Okay? And this is synonymous with the case where you get two roots that are equal, which means delta will be equal to 0. This is the case when delta is equal to 0. Okay? Then the most common case which you will encounter, obviously, the one that you encountered last year, is the one where the discriminant was always greater than 0. So that the graph touched the x-axis at 2 points. So you have an x-intercept there and another x-intercept. And this is the most common case, obviously. Okay? So we are incorporating nature of roots, quadratic function. Okay? Later, when you do the quadratic function, I think next term, if I'm not mistaken, on that term, I need to check the 80. That should be next term. Right? So you encounter this case more often than the first one and the second. Alright? Any questions so far before I move on to example? Okay. Yes. It's mainly quadratic equations. I think I shared it the other day. One of you asked. I remember here writing something. It's mainly quadratic. Remember, you wrote on exponents already, right? The second standardized test, we combined exponents and quadratic equations. So about 60% is on quadratic equations, including nature of roots. The moment you talk about quadratic equation, means it also includes quadratic inequality, nature of roots. All right? Then the rest, it's exponents and sets, which is what you already have done. Yes. Yes.
Sorry, how is the end of year mark calculated?
The end of year mark. The end of year mark is done based on, you see, your assessments they are split into two. There's an examination to written at the end of the year. Generally, that examination contributes 75% to your year mark. All the other assessments, like these investigations, the standardized tests, they contribute 25%. Right? So each assessment out of that 25 has got a specific percentage that it contributes. Okay, I need to check that because I don't want to give you incorrect information. But there's a specific percentage. If I'm not mistaken, some of them are 14%, like the investigation, standardized tests are about 14%. Because they are about
Is yesterday's test important?
yes, because you see, yesterday's test is the first part of your March control test. So that's standardized test 1. The one that you're writing next week is standardized test 2. You're supposed to write one test with all the what? The concepts. So we split them into 2. Are you following that? So the one that you wrote yesterday contributes 50%. The one that you are writing on Tuesday, it contributes 50%. So it's 50-50. Wait. Can you wait? Officially, you've got 2 assessments for term 1. Investigation and a March test. The March test was split into 2. Therefore, the standardized test you wrote yesterday contributes 50%. One on Tuesday, another 50%. Total 100. Overall, 75% of the term. Investigation contributes 25% to your term mark for the report. Yes. Sorry? Yes. Look, if I say, listen, if I say Your test on Tuesday is on quadratic equations. Obviously, it includes simultaneous equations. Because the simultaneous equations that you do, they are quadratic. Okay? For all aspects, for Tuesday's test, all aspects for quadratic equations. Up to the age of it. Okay?
So have you started marking yesterday's test?
No.
Okay. Okay, now I can look you in the eye.
Okay, listen. Listen. Honestly speaking, the test you wrote yesterday was not that challenging. I'm telling you.
So what was 1.8?
Listen, there is. Okay, I'm not sure. I've got the. I don't have the test with me. Right? But listen, I think there's only one question which was a little bit tricky. The last question. Right? The last question required some thinking and a bit of some application. Right? That's all. But the rest. All right.